How are we going to approach this image recognition problem? Each image in the MNIST dataset is 28 pixels by 28 pixels. It's on a grayscale, so we can think about the problem as a 28 by 28 matrix, where input values are from 0 to 1. For example, a handwritten 7 in a matrix would look like this. That's an approximation, but the idea is more or less the same. Now, because all images are of the same size, a 28 by 28 photo will have 784 pixels. The approach for deep networks is to transform or flatten each image into a vector of length 784. So, for each image, we would have 784 inputs. Each input corresponds to the intensity of the color of the corresponding pixel. We will have 784 input units in our input layer. Then we will linearly combine them and add a nonlinearity to get the first hidden layer. For our example, we will build a model with 2 hidden layers. 2 hidden layers are enough to produce a model with very good accuracy. Finally, we will produce the output layer. There are 10 digits, so 10 classes. Therefore, we will have 10 output units in the output layer. The output will then be compared to the targets. We will use one-hot encoding for both the outputs and the targets. For example, the digit 0 will be represented by this vector, while the digit 5 by that one. Okay, since we would like to see the probability of a digit being rightfully labeled, we will use a softmax activation function for the output layer. It is easy to talk about these problems now that you've been through the course, isn't it? So, let me walk you through the action plan. You will quickly notice our curriculum so far has covered everything you need. First, we must outline the model and choose the activation functions we want to employ. Second, we must use the proper TensorFlow syntax to describe our placeholders, variables, and the related operations. Third, we must choose the appropriate advanced optimizers. Fourth, we will divide the dataset into batches for faster learning. Fifth, we will initialize the variables and we will be ready to learn. Sixth, we will make it learn. The algorithm will backpropagate its way to accuracy. At each epoch, we will validate. We will also place some early stopping. Finally, we will test the accuracy of the model regarding the test dataset. Alright, let's get to it.